Okay, so this slide gives us the three methods of charging or transferring electrons. When we charge something, we transfer electrons to it. The first way that we can talk about charging something is by friction, and this is where electrons are wiped from another object when two objects are rubbed together. So, for example, you may have probably all have noticed that when you do laundry, when you take the clothes out of the dryer, especially in the wintertime when the humidity is low, the clothes are often stuck together. That's because they've been rubbing each other and electrons have been wiped and they've become charged. Another example would be rubbing a balloon on your head, and then the balloon will stick to the wall or stick to somebody else. And we've probably all, if you have a little brother or a little sister, we've probably all done things like rub our feet if we're wearing socks, if we rub our stocking feet on the carpet and then run across the room and touch your little brother, you'll give him a shock. What's happening there is that you're literally wiping electrons from the carpet and charging yourself with a negative charge, and then when you touch your little brother, a shock is transferred to him. The next method of charging is by contact, by direct contact. And this is where if you have a charged object and an uncharged object and touch them together, the electrons will transfer to the uncharged object. This is probably the most familiar way that we're used to charging things. What you're literally doing when you charge by contact is that you're making a pathway that allows electrons to flow to the uncharged object. So when you plug in your cell phone or plug in your laptop, that cord that you're plugging in is providing a pathway that allows the electrons to move to whatever it is you're trying to charge. Another example of this, you may have seen people when a car battery dies, you may have seen people connect a battery charger to it. It's usually a small metal box with some like big alligator clip wires, and you plug the box into an electrical outlet and then connect the electrical clips to the car battery and let it sit for a couple of hours, and it will charge the car battery. So what it's doing is transferring electrons to the, it's providing a pathway where electrons can get to the car battery. The last method is charging by induction. Okay, and this is where you rearrange charges in a neutral object without them actually having to be in contact. You can charge things. It turns out that you can charge things just by bringing a charged object near an object with no charge, and that is charging by induction. The most common examples of this today and used today would be induction charging for cell phones and smart watches. If you have a smart watch, you just put it on this little device. There's no actual electrical connections or anything like that. There's no wire being plugged in or anything. You just put the two together and it charges over time. Okay, so charging by induction is where there is no actual contact with a conductor, but the electrons transfer to the uncharged object. Now, one of the advantages of inductive charging is that you don't have any cables or connections to become corroded or to become damaged or anything like that. That's a pretty nice feature. You can imagine that someday, maybe in the relatively near future, we'll all be driving electrical cars, and to charge the car, instead of having to plug it in like today's electric cars, maybe we'll just pull it into our garage or pull it into our parking spot, and it will be charged by induction. There won't be any wires or anything like that that you have to connect to the car. Just getting the car near the charging station will charge it by induction. So that's a nice advantage of inductive charging. You don't have to actually plug anything in or deal with any electrical contacts. The disadvantage of inductive charging is that it's slower. It takes more time because there's not that direct pathway, and by the same reasoning, it's less efficient because there's not that direct conductor pathway. It takes longer and more energy is wasted. But that's charging by induction, where you don't have direct contact. Okay, now our next slide deals with conductors and insulators. Okay, a conductor is a material that allows a charge to be transferred easily. So metals, the earth is a conductor, but what we normally think of as good conductors would be metals. Okay, an insulator is a material that does not transfer charges easily. And insulators would be things like rubber or plastic, wood, glass. Those are things that don't transfer electrons easily. Now let's talk about exactly what that means. What a conductor is something that it's something made out of a material where the atoms do not hold on to their electrons tightly. So metals are good conductors, and electrons can jump from atom to atom to atom. So the electricity can be transferred through metal very well. An insulator is something that does hold on to its electrons tightly. So it's very difficult for an electric charge to be transferred if something is made out of atoms that hold on to their electrons tightly. So where do we find conductors and insulators in the real world? You have a picture on the PowerPoint here of a power pole with power lines. And the lines themselves are often wrapped in an insulator made out of plastic or rubber that keeps the electrons, keeps you from getting shocked if you were to touch them. And those sort of stacked cone things, that's like a glass material. That's also an insulator. Okay. Insulators around the house, the wires that you plug a lamp in or a computer or your cell phone, inside that wire is a metal, usually copper, because that's a good conductor. It allows electrons to move easily, but then you wrap that conductor in plastic, and that keeps you from getting shocked when you handle the wire. So you have an insulator wrapped around the conductor. The conductor's on the inside, that's the metal, and the plastic or rubber on the outside is the insulator. Another good example of where you can see conductors and insulators in the real world is with tools. If you look at the tools that you might use to work on a car, most of them are just made out of metal because there's no real need with a car. There's certain ways that you can get an electric shock working on a car, but most things that you would do when you're working on a car, there's no real danger of a severe electric shock. So you just make the tools out of metal because they're very durable and will last a long time. You don't have to worry about working with a conductor. On the other hand, if you look at the tools that an electrician uses, some parts of the tool may be made out of metal, like the cutters on a pair of wire cutters or the tip of a screwdriver. But if you notice, though, an electrician's tools, the part that the electrician's hand grabs the tool, the part where you come into contact with the tool, is always covered with a very thick insulating material, like a rubber or a plastic. And that keeps the electrician safe when they work with wires that have electrons moving through them. Yet another example is ladders. Every year, lots of people receive powerful electric shocks or even get electrocuted by using an aluminum ladder, and they accidentally touch a power line, and the electricity transfers through the ladder. But if you look at ladders, if you watch electrical workers outside, people working on telephone lines, they use a ladder that's orange. And if you look at those ladders, what they're made out of is fiberglass. It's heavy and it's kind of expensive, but it's an insulator. So if you're working on power lines or anywhere near power lines, you want to use a ladder that's made out of insulator so you don't have to worry about being shocked if the ladder accidentally comes into contact with an electrical line. If you're working away from power lines, then you can use an aluminum ladder that's much cheaper and much lighter and easier to maneuver. About grounding. It says up here that the earth, you can conduct electricity to the earth, and what that's called is called grounding. And grounding's a pretty important idea to understand. For example, you've probably noticed that some electrical devices have the plug into the wall has like a third prong, a prong at the bottom. And that's what that is a ground. If you were to look at the electrical wiring in your house, the part that connects to, those wires attach to pipes in your house, pipes that are made out of metal. And where do the metal pipes in a house or an apartment building go? They go into the ground. So what that means, the earth, they go into the ground or the earth. What that means then is that when there is an electrical problem, a short circuit or something like that, the electricity, instead of going into the person, it goes into the earth. It's grounded. Okay. Another example of this grounding that you can see is you may have noticed that some houses and lots of buildings have what's called lightning rods. They're like a metal spike on the roof. And if you look at those lightning rods, those metal spikes, they all have a thick metal wire that goes from that spike on the roof, runs down the side of the building, and goes right into the ground or the earth. And what that does, if lightning were to strike that building, it is conducted safely through the wire and into the earth. It's grounded. Okay. Now, the last slide shows some videos here, mainly of static electricity. And grounding, the first one is very interesting. It shows how static electricity can start a fire at a gas station. And grounding is very important there. When you're in your car and you slide around on the seat and move your hands and stuff on plastic parts in the car, you can build up an electric charge. And that electric charge, under some circumstances, can start a fire at a gas station with the gasoline. So what you want to do when you get gas, you always want to take a moment to ground yourself before you handle the fuel pump. And the way you do that is once you get out of the car, touch the metal surface of the car or touch part of the building or something like that, but do something to discharge any electrical charge that you have before you handle the gas pump. Okay, so take a look at that video, the static electricity gas station, and then the other ones, the Van de Graaff generator is kind of long, but you can look through that and see how static electricity can be transferred. But then the other ones are very short. The baby's hair going down a slide, the cat and the dog, they're really funny. You can look at some static electricity where you're wiping electrons from one object to another object. Okay, so look at those, and there will be some questions on your assignment on static electricity on these videos. So make sure you view them all.